Well, congratulations. You've won an Oscar. Yep, see those two people? They're carrying that Oscar. Wow. Man, I wish I had won that big too. But, they don't actually win one that big. That statue is like 6 times as big, and an Oscar weighs about 8.5 pounds. So if the statue was made of the same material, I think it would be heavier. We're going to learn today how to figure out how much heavier it would be. Let's take a peek at an example. So first of all, when we talk about similar polyhedron, they're similar when their faces are similar sizes and their edges are proportional. So if you take a look at the two cones, it looks like the radii are in the ratio of 8 to 12, and the height are in the ratio of 14 to 21. Can you see that they both reduce to 2/3? So therefore, these two are similar. And when you look at the bottom ones, even though 7 doubled is 14 and 3 doubled is 6, that would have to be a 4 in order for them to be similar. So those two down there are not. So let's play a little bit. So here we go. We got a figure, just a regular rectangular prism. And if I want to find its volume, I got to multiply the length times the width times the height. 4 times 10 times 3. So the volume would be 120 cubic inches. Now, let's suppose that we have one that's a lot bigger. Let's say we triple all the sides. We make them 3 times larger. So we got this big old prism diagram, not necessarily drawn to scale. So now everything is 3 times bigger. So this is 12 inches now. 10 times 3, that's 30 inches. And the depth, 3 times 3, 9 inches. The volume of this one is 12 times 30 times 9, and that's 3,240 cubic inches. So how are these volumes related? How many of the little boxes would fit into the big one? If I divide their volumes, I can figure out. So if I do 3,240 divided by 120, my calculator tells me that's 27. So 27 of those little boxes fit inside the big one. So the question is, the scale factor was 3. What do I do to volumes to this? How does that scale factor change? So what do I do to 3 to get up to 27? So do you realize that if you cube 3, you get to 27? 3 cubed is 27, yeah. So it's very similar to the area we did last time. If the volumes are proportional, the ratio is going to be m over n cubed, or m cubed to n cubed, which should make sense. If area was a squared relationship, and area is square units, wouldn't volume be a cubed relationship and thus cubed units? It should probably work that way. That should make sense. So let's play with some problems then. Suppose I know that the ratio of the heights of 2 similar cylinders is 2 to 3. So if the heights have that ratio, then the volumes are going to be in a cubed ratio to them. So the volume ratio is going to be 2/3 cubed. So 2 cubed is 8, 3 cubed is 27. So the ratio of their volumes is 8 to 27. And now we can solve the problem with that. What we can do is we can say this ratio of their volumes, 2/3 cubed, or 8/27. The smaller cylinder has a volume of 160 pi, and we want to know the volume of the larger cylinder. All right, let me give you a little hint about solving this equation. What I'm going to do is I'm going to pretend that the pi isn't here for a second, because now I can solve and I can express my answer then in terms of pi by putting it back in. So if I do 27 times 160 and divide it by 8, if I just do 27 times 160 equals 8x, when I solve that, I get x equals 540. So my volume, then I got to put the pi back in. So my volume is going to be 540 pi. Pi is that constant. We can just kind of cancel it out or hold it off before we put it back in. Hey, so let's do this. Let's go back to that problem in the beginning for a minute. How heavy is that figure? How heavy is that statue? Well, if the statue is 6 times as big, okay, so if we do cubing 1 to 6, that's going to be 1 over 216. And if I know that the real one weighs 8.5 ounces, if I solve this for W, that's how much it weighs. So if I cross multiply and do that, the weight is 1,836 pounds. Holy cow, those guys are really strong. You see his shirt, it says on it, Vancouver 1986. Man, that's an old picture. Or do you like the other guy's mullet? I love it. So, one last one to think about. If you see a soccer ball, its diameter is about 9 inches. A tennis ball is about 2.5 inches in diameter. They are filled with air. So how much more air goes into a soccer ball than a tennis ball? How many more times is I don't know. You know what I'm trying to say. I want to figure out what the volume difference is. How many tennis ball volumes would fit inside a soccer ball volume? So if you remember how to find the volume of a sphere, the volume of a sphere is 4/3 pi r cubed. So if I can find those volumes out, I can figure out what that value is. So let's see now. I know that the diameters are 2.5 to 9. So if I take this 2.5 to 9 and I cube that volume, I don't even need to figure out what those actual volumes are. How about that? All I got to do is go to my calculator and cube each of those. If I cube 2.5, I get 15.6. I should actually be doing this the other way around because I want to know how many more times is the soccer ball compared to the tennis ball. So if I do 9 divided by 2.5, I know that the diameter is 3.6 times bigger. If I now cube 3.6, the volume of the soccer ball is about 46.656 times larger. Pretty darn big there. Yeah, so if you know the ratio of the diameters, you know the ratio of the volumes. Pretty cool stuff.